Good morning, everyone. Welcome back to the session. Today, this is going to be my agenda, right? So, um, uh, it's same as the session one. This is going to more focus on the autonomous. So, uh, let's talk about the AGV, right? I think I have been in the simulation industry for at least closer to 20 years, okay? And I handle different customers, automotive, aerospace, and there are different customers. And I hardly there are robotics is or autonomous is not very new, but I hardly see the interest until last 3 years, right? What makes that the industry to look forward this product or this industry is all COVID, right? So suddenly when COVID comes and people have, and there's no people to deliver medicine, there's no people to work on the shop floors, then that's where the companies are looking for the solutions. Okay, and I start to see so many interest, and I start to see so many companies jumping into that. And then but now it's COVID is gone, almost gone, and people are back to the life. But of course, once you taste it, you always want to have it, right? So that's where companies are looking into the saving cost and following the efficient way to improve and make it more faster. So now going back to this topic, AGV and so on. The first thing is looking at the design aspect. The most important is the flexibility. The flexibility means today I may carry a product with a 5 kg, the next day it could be a 10 kg or 7 kg, right? So how this could carry and how I can redesign this product and that thing. The second thing is also time is money, right? So how fast I can operate this vehicle to carry the things and so that it can give me the maximum revenue back. Then same as one morning I mentioned, the most important is how it's not how good your product is. The most important is good product come to the market faster. Okay, that's the most important. Everybody rushing for the time and make only those bring the product faster is the winner and survive in the market, right? So these are the challenges that the AGVs and AMR manufacturer or designers face it. So, and this is what I want to share also how that we see as a market, how the market is being potential. Okay, and you can see in this is also around 2020 fact, and you can see almost 550 plus companies are looking into that. All right, so looking into developing the different concepts and they see this as a logistics as one of the bigger things. So now, what are the requirements? Okay, if you are going to design the new AGV, what are the typical challenge? Okay, so the first one is sizing and validation. It's the same as with the previous session. The sizing and validation. So AGV is going to work within the batteries and motor. So this is need to be optimized. Okay, so I cannot put too much power when there's a battery in less capacity. So I need to optimally balance so that I put the right motor and as well as the right size battery. Then you can also second thing is how this is going to work in the actual environment, virtual commissioning. Right? Then the third one is if this is autonomous, how it takes the decision, how it senses, and how it takes the decisions need to be also simulated. Then the third one is range, because this is the what everybody want to maximize, right? So how much I can get that in the single charge. Then you can see that the other two things are more related to how this is going to perform in the real world, right? So how it can sense the environment, how it can integrate the rest of the things like a material handling, if you have a pick and place, or if you have any specific arms, and how this is going to work. So now, this one slide that summarize what we have, right? What are the solutions? So if you see the topmost solutions, we call it as a system solution, and that can validate the designs much before you build the CAD models. Okay, so you can think about using the X number of batteries in series and cell parallel then you can take the motors and see how this is going to work before the CAD model. The second set of solutions are talking about that we call it as a 3D simulation. Basically, what it does is you bring your CAD model, your CAD geometry, then you simulate that for structures, how strong it is, how this is going to behave in terms of the stability and all. The third one is more about test. So whatever we simulate, we need to also verify that this is accurate. So we have the test equipments. We can see there are a number of data acquisition systems and as well as that test related software. So I go one by one, just to brief that. So the first one is the system simulation, and in this system simulation, you can see this value. The whole AGV is comprises of multiple systems. You have a mechanical systems, you have electricals, controls, there are multiple things. They all have to behave together. So this solution helps to build your model in the virtual form. You can see there's electrical fluids, thermal, mechanicals, and so on. But basically, this is if you ask me another word, I would call this as a Lego blocks of engineers, right? So you can see here each blocks you can stack together and then you can build your models, okay, and validate your models. And then the advantage of this is you can see in this picture, this is a green color, and this you can see this is a purple color, right? This is electrical. So each color represents a different set of physics. So basically, you bring a battery, then you wire it, you connect the motor, then the motor brings the electrical energy to the mechanical energy. Then you use the gear systems, that is the mechanical systems. Then if there is a heat dissipation or something you want to dissipate, there's a thermal models. So in a way, it is a Lego block. You stack together and see how that the whole system behaves, how long you can operate, and then you estimate. So the next set of solution is more specific. The previous one is a solution for mechatronic system. So you bring different systems together. The next one is more on autonomous specific solutions. But here you can see how this tool is working. So basically, autonomous systems that they behave in the same way humans, how we recognize the environment and how we take the decision based on that. So the only difference is they use camera, radar, LiDAR, ultrasonic. So these inputs need to be validated. This input need to be collected. Then you develop the algorithms based on the recognition. Then you take the decision, the systems. And these control logics, these algorithms need to be verified. So in case you probably see a person or maybe somebody is moving, then this UAV, you can decide this UAV need to be stopped, or maybe take a left hand and go, or maybe take a right hand and go, right? So this need to be validated on the basis of how you develop the algorithm based on the radar inputs and so on. So basically, the pre-scan solution is a tool that can also talk with our the previous system simulation EMC, right? They can talk together. So this tool verify your control algorithms and as well as autonomous capabilities, whereas the rest of the whole vehicle behavior can be verified in the SimCenter EMC. So the other one capability is also important is the steering capability. So if the AGV is loaded with the materials, how this can stop, and when it stops, it will it lose its stability? Will it topple? Right. So that is possible to also simulate. Here in the left, you can see the same color coding. It's the same as the previous one. One is on the electrical systems. Then the second one is the vehicle dynamics. Vehicle dynamics is the physics that simulate how the vehicle will behave. Okay, can it turn, right, or will it topple? So this solution, and the next one is the control solution. So these three are modeled in this. Then you can see. Yeah, you can see in now the animation. Here you are modeling the AGV, and you can see some of the physics is in the electrical systems. Then they are connected to the mechanical systems. That is a tire and the gear box, then the electric motor. So then you can define your trajectory, okay, at which this AGV need to go, right? Then you can also trigger the scenarios of acceleration and steady speed and stop. Then you run the simulation. It can simulate the battery behavior as well as the vehicle behavior. So the next one I wanted to talk about is the results. Okay, for example, what is the maximum speed I can use it? Okay, so and what if I increase my height of the load, right? So these are the different scenarios. So if you see here, this is the solution that by increasing the height, how or increasing the speed, how this will deviate from the original supposed to be a trajectory, right? So same thing, it goes for the velocity increase at a different trajectories. You can see that the performance. Then you can also see another studies by increasing the weight. Okay, so of course, if you increase the weight, the electric motor is going to lose its speed, and also, but it's you can also see that how that the trajectory is going to change it, right? So yeah, there's a height increase, the shape of the trajectories. And the next one I wanted to talk about the solutions for PLC automation. Okay, so this is once the product is ready and you want to see how this could be automated through the PLC. So here we have the connections with this Siemens other business unit, and we have the tight integration in that solutions. In the left side, you can see there's a virtual controller, and this controller can be simulated with this model what you prepared. What is the advantage is before you deploy this in the product in the actual world, you know how this is going to work, and you can virtually fine tune your PLCs, right? So your PLCs against your product. And there are two ways to do it. One is called hardware in the loop. The second one is in the software in the loop. And the second one, without the physical hardware, you almost mimic everything what you have. But the second one is when you have a physical hardware, physical or real PLC, then you can connect or exchange with your PLC data. That's a two difference. Both are possible when you have a models in the AMC. So this is one of our case study that I wanted to share, SIMO, right? And here, how that the concurrent engineering, the hardware and the software in the loop work together, and how this can be validated in the various stages of the development. The next one I wanted to talk about is more on the software in the loop. So in the software in the loop, one of the things, probably you have a teams that is doing different things at the same time. So you, for example, if you have a controls team that is using a MATLAB, or if you have some mechanical team that is using the CAD models and mechanical models, these solutions can connect with the different systems, and then they can you can optimally fine tune your physical models. If you change the motor, what will be the impact? In the mechanical aspect, it is going to affect some of the stability. But if you modify some controls, you can also fine tune the control logics in this. The next one I want to talk about the interactions with the surrounding, right? So this is about our autonomous solution. So the autonomous solutions, you can see, as I mentioned, one of the things that you probably want to buy from the suppliers and integrate is a drive system, or probably you use you also buy the batteries and so on. Here there are a number of battery models, and you also have a drive models. So you can just drag and drop like a Lego block and build this whole system. What if you change this? What if you change the tire? Or what if you change drive or mechanic gearbox? You can see the influence of driving distance or charging frequencies and so. The next one is very unique way you can create your environment. So the AGV could be used in the shop floor, or the AGV could be used in the town city area, or it could be used in the airport. So here the solution is you can create a virtual environment, right? So you can create a roads, there are obstructions, then you also create some of the pedestrian movements or something. You can create these models. It comes with a lot of libraries. So if the AGV is going to handle, let's say if something is in the rainy conditions, or if there is snow conditions, or if there is a water, you can model the different environment. So in this video, you can see that you can create pellets, right, in the shop floor. You can also see that there is an obstruction. So once you create these obstructions, you can visualize in the 3D model, right? So you can see there are some obstructions for the AGVs. Then you can also create the pedestrians, right, or the workers. So what should this AGV do when someone crosses the path, right? So that scenario can be triggered also, right? So this then you add the sensor model. Okay, what sensor you are using? Of course, the sensor you probably buy from different suppliers. So you can configure the sensor models, radar models. Then you develop your algorithm, right? So basically, you create your mechatronic systems, then you create the environment, then you model your sensors and configure, then you run this, validate your models, okay, how the AGV should behave at that particular scenario. Should it stop or should it bypass? So you can see here this simulation model that runs that based on your sensors, based on the environment. Then you can see if it is stopping, right? So you can run these animations to see how the AGV is going to behave. So this is about overall solution, right? Now the next one I wanted to talk about, this is our customer case study, right? So the customer uses our solution, that is Siemens AMC, and they use this to validate the models. Okay, then you can see the testimony of the customer. Just give me. Sorry, the audio not. Okay, so I just showed that how that our customer case study, right? So how they build this model and how they integrate and simulate the charging and discharging, and as well as that the different kind of architectures, and how this AGV respond to the environment given its sense and different surroundings. So here, what you do is it carries the weight, and as well as it follow the person, right? So it need to take certain decisions in terms of the obstruction, and these obstructions are can be modeled in pre-scan. Then, but the rest of the vehicles systems is modeled in the AMC. So in this left side screen, what you are seeing is the Siemens AMC model, and you are seeing number of graphs, but basically the software is capable to simulate the driving range, how fast it can go, and velocity, accelerations. You can name it different parameters from the simulations. So basically, it's just follow the person, right? So it and carries loads. So this is also again, it's a French startup, our customer. So like I mentioned before, we have a startup program specifically if we are, startup want to leverage our end-to-end solutions. You can feel free to engage Melvin and his wife. We have we can do the same as what we have done with the Twinsfield. We can support this with our startup program. The second thing is also if you are academic, we have an academic program. The academic program is not just throwing a bunch of software, but the most important is how to teach the students. We have extensive learning curriculums, so the professor can assign the courses to the students, and when they complete, you can also assign the certification to the students, which will help lifelong in the LinkedIn profile. You can see that the Siemens endorsement on that particular course completion, and that will be useful in the career as well, right? So we have that program as well for the academic program. And the other thing is also it makes very easy job for that professors and as well as the teaching faculties. The reason is because all these courses are already pre-built in, so the students can self-learn at their own free time, and you can also see that how and when they finish it. And also, it's almost the inside. There is a same as that lecturer. There is a courses. Someone conduct the course as in the video recording. You can watch and learn this program, right? So that's where you it will be very useful for. Don't need to spend time to teach, but it can be self-learn these technologies. So, this is these two are the things that I wanted to highlight. One is for the startup, and the second one is for the faculties. Then the other thing is what I also want to highlight, the tool that AI driving agent. Okay, how we can fine tune the AI algorithm by sensing and adapting based on what it learned from the physics. So in this capability. There is a mechatronic physics model inside, and this mechatronic model is going to learn, going to simulate how this product is working. So, in case this product is experiencing an innovative situation, it can quickly validate that the particular scenario in the simulation model. One of the example I can say, probably when they design it, they may never come across a situation of encountering the snow, or encountering the wet floor, or maybe other scenario. But what will happen is if you have a physics AI-driven agent, the software knows the physics of how the friction is going to change, how this is going to affect the tire grip with the road. So if the vehicle apply the brake, it may skid. Okay, based on that. This skidding can be simulated by the physics, right? So that is possible in this simulation. The next one I also want to talk about battery range and charging. Okay, one of the main challenges, when we design it, we need to precisely size that the number of cells in series, number of cells in the parallel, so that we cater this size the battery. So here the battery pack simulation capability that can, if you have a supplier data sheet, you can import and create the models. Then if you have a electric motor models, you can bring that particular motor and drive this and see how long it can drive with that particular distance. So later in the slide also you will see you can create a different kind of scenario, right? Your tracks and also the loops you can create. So you know how long, how many hours you can operate, and how many times in a day you need to charge, whether you have a sufficient backup plan and so on, right? You can plan it in well advance when you are designing it. So, the second one I want to talk about is scenarios of charging and discharging one. So of course, when we design the battery pack, one of the main consideration is charging and discharging, and as well as the operating conditions. We don't want to spend whole night charging, and in 2 hours it drain again, it go for the charging. So we need to factor these operating conditions. So you can define the loops, how many times it is going to make a turn or going to operate in the shop floor before it goes to the discharge charge, and then it how many times how many hours you can operate to get the maximum output. And in case if this is not going to cater for the full hours, let's say the workers are working for 8 hours, if this is going to supply maybe only for 4 hours, how many backups you need it, right? So all this can be planned. So you can apply the different loading conditions. You can also see that the charging and as well as the loading and driving scenarios. Then you calculate the operating conditions. The next, or I would call it as my the solution that what I wanted to calculate is the simulation capabilities related to the different scenarios, okay, testing scenarios with the battery SOC conditions. Okay, so one of the factors is if I am going to give a warranty of 2 year or 3 year, I need to make sure my battery SOC or battery conditions is still valid at that period. Otherwise, I will end up with all the recall requests. So here you can model the battery aging capabilities and also different SOC conditions. Okay, so we cannot expect every time, every scenario, the battery is in the full condition. So in this simulation capabilities, you see that the simulation results are comparing with the different load conditions, whether the AGV is fully loaded or partially loaded, then how this is going to affect the duration of the operation and as well as the SOC conditions. Okay, then this is just to summarize my capabilities, right? So the capabilities, in the beginning, I talk about the mechatronic solutions. The mechatronic solutions helps to build a model which is electrical, typical mechanical systems, and also thermal models are the common use case. But then the second one I was talking about, the autonomous capability. The autonomous capability can be integrated into the mechatronic system so that whatever that logics algorithms we develop or in junction with the mechatronic simulations validated and how these AGVs behave in this. Then next one is the productivity, right? The conventional method of loading and unloading and how efficient is this? Is it worth to invest because of the downtime in charging and discharging? We can also simulate that. Right? Then we also the capabilities, maximize that the payload. If you increase the load, how how much that the distance or range is decreased, and those kind of simulations. And when I summarize that, all other things, whether I want to have a reduced time or prototype, it's all into a virtual form. Everything, whatever I am talking, is in the virtual form. So I don't spend on my money, time on prototypes. Okay, this helps me to almost certain my model is going to work. And changing here is almost a few minutes or a few hours of work. Whereas if you change the physical prototype, you probably spend thousands of dollars and as well as the manpower and days of working, right? So this is the place the simulation helps to bring the product much faster and as well as that in the lesser cost, right? That's all about my session. Feel free to let me know if you have any questions, and I'm happy to answer. And in case if you have any other things that you also interested in this, we are here. Yeah, feel free to reach out. Okay, so, thank you.
Winston, Melvin. Thank you, everyone. For those who are interested to get some of the good materials that were published, that were shown to you before, you can just scan this QR code, or we'll send it. You can get it, the material straight away. But also, if you need it, and then just let me know, let us know so that we can provide it to you. as well. So of course, we now open for Q&A if any. So if you have any questions, just let us know. We can just try to attempt to answer it, Winston especially. So yeah, anyone, any questions? Yes, perhaps introduce yourself, identify yourself.
I'm Benjamin Dumas from GFP Expertise. Did you work in high accurate agriculture with this type of program and for farming, but with animals for automatic systems?
So, for agriculture purposes.
Yes, high accurate agriculture.
The company is called Accurate Agriculture.
I don't know. It's for doing if you model work for this field or not.
Okay.
Whether it will
Okay.
work in agriculture.
Yeah.
Okay.
Yes, yeah, it can work. Okay, there are a few things that we need to consider additional. One of the main consideration is in the agriculture side. The first consideration is that the floor is not going to be something like this. So we have that another product that can model different kind of soil conditions. So whether you are it's a muddy or rock or sand. That is possible. That the second scenario is in case of you model different kind of scenarios, plowing or spraying. All this need to be modeled in CFD. Okay, the flows specific simulations. So those information and as well as the soil conditions, this tool won't do it, but that it can be coupled with the different physics. For example, you model with this whole model, but only the tire conditions we can simulate with the different soil. Then you can loop back the data to this software so that you can size the motor, whether this motor is going to stuck or the tire is not sufficiently having a width or it sink inside that the muddy conditions or not. So we have a, but it's not just specific to AGV. We have our customers designing the tractors and all with the different soils. So, but that physics need to be coupled or added to here. Okay, so but the rest of the mechatronics are already inside this. It's just the behavior with respect to the environment is not inside. Okay, so that's why. But it is possible.
Thank you. Yes.
Yeah, this is Hamza here. One of the questions I have was what kind of package do you guys have?
Okay. For startup.
Okay, so okay, if you see that in our solution, it talks about the concept to the validation. So from the moment when if I go back to my slides. Here, not here, right? So all our solutions are categorized into these three, right? The first one is the moment we think about the product, but I have no CAD data, right? I have some ideas, so I want to simulate how this is going to work. So this is called system simulation. The second one is about when I have an actual CAD model, right? So I have a CAD geometries and I want to see how this is going to work. So these are the different stages of the product development. So in the startup package, what we do is we offer the solutions of this whole set of solutions. Okay, so you have a CAD model, you have a CAD software, you have a simulation tool that can validate in the very, very early stage of concept, and you also have a simulation tools that you can categorize. Test is depending on whether you are really going to do the test or not. In case if you are going to do the test, you can just add in the startup package. Okay, so that is what we. So it is a kind of program where that you can leverage that these programs, the software at a much attractive way. But as you see here in this video, we also make a promotional contribution, right? So it's a kind of win-win situation for both. Siemens will take your references, how you successfully use this our tools to bring your product. So like this, this is one of our customer, how he, and we also market. If you go to Siemens website or some of the public domain website, Siemens will also take the initiative to market, make the known name visible to similar customers in the outside. So it's kind of like a win-win situation for this. The only thing that the startup program, it cannot be too long, too big, right? So it is, yeah. So other than that, if someone start a new company, you can entitle you can entitle this all these technologies at a very attractive solution. And it comes with the training materials also. All this it is almost similar as what we offer for academic program, but the difference is in the academic the faculties can assign the courses for the students. Here it's directly the person who buy this, he will use all these programs
So my second question would be on electric houses. So what kind of showcase that you have or pilot tests you've done in Southeast Asia, for example? The showcase for pilot for exhibition.
Okay, so we have several customers, in fact, in Indonesia and as well as in Vietnam, but I won't call that as a AGV, right? It's not yet into that stage. So, the answer is we have a AGV customers. We also see the agriculture customers, but I didn't come across that doing both. Okay, that's my answer, at least in here in the Southeast Asia.
Southeast Asia is AGV.
Yeah, we have a AGV and as well as that agriculture specific customers, but yeah, but I didn't come across that the customer doing both. One.
What sort of function that they're doing in that particular case?
Okay, the one I was referring is more on the plowing, right? Plowing on the field. Yeah, it's but I won't call it as autonomous. It's kind of semi, or you can consider as a remote kind of operated still, right? It's not yet to the autonomous kind of. But again, AGV customers are also there, but I never see anyone going into agriculture. Most of the people are in the reason, if you recall in the very beginning of the discussion, no, I hardly see the interest before the COVID. Right, only when the COVID comes, lockdown comes, people there are not many workers in the shop floor, and everybody looking after the factory specific AGVs. Right, so the AGVs for agriculture is still very new, and I think it's innovative. Right, it should be a new market.
Okay. Thank you, Aniza. Yes, next we have Mr. Please identify yourself, sir.
So, okay, my name is Ishraq from DJI. Okay, so just a little fun side question. My question is regarding the 3D modeling and drone part. Okay, are you familiar with Star Wars or Star Trek?
Not much. Okay, maybe.
But you know there is all this, right? Okay. So my question is, will there be any chance in the future we will be seeing drones similar to spaceships in Star Wars style? Just your opinion.
Okay. Okay. I personally feel nothing is impossible, right? I think it's all about how the technology evolves. Okay, that's what I can answer. Okay.
Since Star Wars physics is kind of like impossible to replicate in the real world.
Yeah.
It's like okay, if you can Google it, maybe Google TIE, fighter, right, and see the shape. Is for me an easy explanation is like an egg, chicken egg with wings that can fly. So I don't know, maybe in the future I would like something like that
So
to
you
fly.
can use your software to simulate.
Yeah, definitely. That's what simulation does, right?
Will take off.
Yeah. You can definitely apply the simulation tool to verify. But I personally feel that nothing is impossible, because if you see even that the same era of movies, at that time people never talk about the Mars, right? You see that it's all like a imaginary one. But today people reaches the Mars. Not people actually said that the Mars rover and all this. So it could be definitely possible. Okay, just need to simulate and see whether this, or need to change it, make it lighter, or make it some few other concepts. Yeah, but I think it should be possible.
Thank you.
Leading on to this question, right? My question is that in terms of the design stage, right, and the libraries of the design, the materials and all that, like, how often is it updated with the latest materials and all that, so that they can build something that is new?
Okay, yes. So if you see here, okay, so in this slide, there are two things I wanted to answer, right? The first one is the physics or the equations that capture the behavior of the systems, okay, electrical or how this. So we have, if you see here in this, around 6,500 validated model. Validated model means if I supply a current and 10-kilometer range, and the wire diameter, and what will be my drop, okay, what will be my power loss. These are the common validated equations already available. And if you see here, this is every versions we add these libraries, okay, depending on when our customer uses. Sometimes when customer requests some capabilities, we keep adding. In fact, 4 years ago we were in the 4,000, and now we are in the 6,500 plus
And
equations.
that is contributed by your
Mostly by our customers, right? So if a customer tomorrow try something new and say that all your physics are not suitable, or maybe we have done this test, and this is what we get this, and we need you to develop this. Then we develop the physics or equations to capture that phenomena. So there is a model that is still evolving. I won't call that it's 100%, but I would say worldwide, most of the if you look into automotive or aerospace, almost every customer uses the solution. So most of the engineering problems are inside these equations. But still, there are some, always we come across new materials, innovative materials. But Siemens always, when something new comes, we invest also heavily on that particular technology. If you talk about just within less than 5 years, additive manufacturing is one of the things. So when conventionally we take a material, we take this and subtract and produce the material. When 3D printing comes, everybody, oh, okay, this is a very new. So we saw that as a new technology that will definitely changes the whole world manufacturing. We invested, but when we develop this capability, yes, it looks like a very new. But after you manufacture the product in the 3D printing, it brings new probability. Even you take a steel or you take a plastic, you 3D print, its behavior could be different, because the way you melt material and then you manufacture it compared to the conventional way of molding and you cool it, the same material would have a different behavior. Then we add some additional capabilities. Okay, if you do this way, the 3D printing, the thermal distortion could be different. Okay, and the residual stress could be different. So we develop this. So engineering is a constant evaluation, right? So we keep adding the capabilities.
like Steve Jobs will always challenge the norm, right?
Yes, yes.
Okay. Thank you, Grace. Winston. Yes, please, sir.
Hi, my name is Daniel. So a typical HEV like is usually equipped with different sensors like cameras, radar,
Radars.
sonic. And so because of its safety tech surrounding, right? Now there's this one innovative company Tesla. And what they've been doing is that they are actually removing all the other sensors. Okay, they are just leaving camera itself. They just use vision. They just take surroundings with more complex, autonomous driving environments. So I want to ask about your point of view. Okay, what is your view about being disabling all those sensors just on the camera itself? And what do you think those other sensors are there even necessary for all of the automotive
Yeah, it's the only way we develop the product better, right? I think it may not be ready today. It may not be feasible. It may be just still dreaming for that. But I think it would be possible. Okay, and if you remember iPhone a few years ago, there is no Face ID, right? Then people are thinking whether the camera can use the face as a security, right? So it was not possible. But now it's a default security in almost everywhere, right? So it is possible. Okay, it's just how robust it takes some time. Okay, how iPhone use the face recognition using the camera as a security. It should be possible. That's what my opinion is. Just 5 year or 2 year or 10 year. We don't know. Okay, but definitely seem like how the headlights. There may be 4 or 5 or depending on the cameras, the cost, the sense, the behaviors, environment surrounding this. I'm technical people. I believe in technical, right? So we have to believe. Okay,
Okay. Thank you, Winston. Thank you, sir. Any more questions? Yeah, please identify yourself.
From finance as their solution engineer. So I want to know, since center everything is it limited to Siemens product or can be used widely to any microcomputer or any PLC?
Okay, so this is Siemens principle, right? We believe in open system, right? We don't believe in a closed or monopolizing the market. Okay, when as a customer, if you are developing the product, we know that you probably use multiple product. Okay, so all of our product, our principle is open. So our tools are compatible. Let me go. Yeah, so every tool that I'm showing you is open. Open in the sense that our IPs are inside our software, right? But at the same time, if you want to link this software to even our competitor or even your in-house code, there is a provision embedded. Okay, so if you are using Python or if you are using MATLAB or any other tools for controls, or if you are using other hardware in the loop devices, our tools are designed to work with most of the third-party product in this. Right? Otherwise, it's not a practical solution. We cannot expect everything is in Siemens and you develop the product. Almost every product. If you are using different CAD, yes, you can use your simulation tool to our product. Same thing if we use our test, but using different tools, yes, we can use it. Okay, every systems are open and compatible. Okay, so you can just use only the system on the solution. The rest would be the product, or you can use this solution.
Thank you, Shafiq. Thank you, Winston. So, any more questions from the
So is
floor?
there like a trial version that can try out? You have?
Okay, yes, okay. So I think there are some products that is not a student version for academics. Then there are some versions you can also download the free trial. I think some of the product, I think you can look into the website. If you don't see this product in the website, you can always reach out to Melvin, right? We can arrange the trial. Okay. The reason is because all these softwares are, not all, okay, some of the softwares are highly specialized, strictly under the US export compliance. Some of the softwares are not so strict as that. So those are very easily downloadable. You can see in the website itself, there is a 30 days trial. Okay. I know this product is in the trial. I know some of the product in this trial, but if you don't see, but you are interested, yeah, feel free to let us know. Then we can arrange.
So I think it's good to contact me. So we don't have to. Fine.
Yeah.
So yeah, contact person Melvin here in Malaysia. So thank you, Grace, Winston, Melvin. Any more perhaps last questions?
Just a fun question. Very fun question. How do you deal with pirated version of your software?
Sorry, how?
How do you deal with pirated version of your software?
It's a tricky question, right? You are asking how our IP can be taken away, right?
Yeah.
So it's
Are there any in the market?
huh?
Are there any in the market?
Just in case
I
you
don't
find
know,
the right
right? I really don't know, right? It's whether it's available or not.
Good answer.
Yeah.
So most probably it doesn't exist in the market.
I think it probably available, okay, but it's just we don't know, or at least I don't know. But you know, in any place, right? You
Maybe the library is not updated. Maybe you only have 10 validated model instead of
Maybe,
6,000.
yeah. Maybe it's the last year version, but who knows, right?
Yeah. Just speculating.
One question I want to ask is, have you guys partnered with any universities in terms of running programs or so product in local universities?
Malaysia local university, yes.
okay, we have some programs going with the different universities, but I don't have the name at moment. But I know some of the programs already going. But in Singapore, Vietnam, Thailand, we have a very big partnership with some of the major universities in a very big scale, multi-department level. But in Malaysia, I don't think it's a very university level, but there are some programs going on as a department specific. Some departments have some interest, so they have some of the tie-up. But mostly all our main activities are in Singapore, Vietnam.
When you say department, what do you mean by department?
So sometimes just one department come and ask, right? Like aerospace or maybe mechanical department want us to work with us, and then we arrange it. But in some places, for example, in Vietnam, we have a ministry level tie-up. So all the universities have some special programs directly from the ministry level. So it's all depending on the countries and depending on university. So for some in Thailand, we have the university itself have a tie-up. They implement a lot of our solutions, electrical, mechanical, aerospace. There are different things, but the tie-up is directly with the university. So we have a different type of programs. But depending on the university interest also, right? So how the
Because it's very important to start with these universities to run the programs, because especially related to robotics or
Yes.
right?
Okay.
Because not individual can actually have that capability to subscribe to solution.
Yes.
At the same time, also you are nurturing the youngsters move into this simulation. So that's one of the areas that you sell in the market.
Okay. We have a different program in US, NTU, SUTD, SIT in Singapore. If you are talking about the robotics, it covers almost A to Z of Siemens solutions. You have a CAD, you have a robotics specific solutions, technomatics, robotics, almost everything, in the line building, everything is in the Siemens is available, in case if you want to. And that, especially when it is in a full program level, we have also the university level curriculum. So each year you can assign some of the courses also to the students. So on top of your regular curriculum, they can also go to Siemens portal. They can see how the robotics programming, right? So then, or they can learn something on designing the controls, something on mechatronic systems. They can learn each term, then they can get it. Okay, so you can create your IDs for the students and you can assign.
Okay. Thank you, Haniza. Thank you, Winston, and also thank you, Melvin.